Welcome back to the stream, anyone who's joining us early, right after I press record. There's Tuco already. Tuco wants to play. I'm gonna get the camera in position for a little of that. There's the little dude. Tuco, you're already disassembling this feather. Oh my gosh. He's taking this thing apart. Oh. Got it? Think it's gonna get away? No, he's pretty got it. This is a much more typical cat toy, Tuco. Oh my jeez. Duke, that was quite a jump. Sensei is asking if I've ever flown B-52s. You mean like the full-size aircraft? No, definitely not. Oh man, Tuco is pretty into that toy. He also really likes this mouse, the one we got in the mail yesterday from Dory. Don't mind me, I'm just going to catch up on drinking this coffee while Tuco shreds that feather. Oh, I guess Sensei was asking because of the flight suit. And I got this because of its flame resistancy, not because of its military standard. That was for a project I did a while ago where I was running around lighting pilot lights around a bunch of fire effects, but nowadays it's just something comfortable to wear around the shop sometimes. Are you mad because it's no longer running away from you? This is going to be really good once we have a better aerial camera for that kind of thing. It's always the problem I have. Do I I play with the cat, or do I work on the robot that's going to help make playing with the cat more awesome? Jesus, getting along around. Is this more your jam? No? He just took that stick right with him. He does that a lot. Like if we're playing with this upstairs, he'll take the entire toy, including the stick, back downstairs and just put it wherever he wants. Yeah. Yeah, I agree with Vince who says, I love Tuke's paws. Makes him look like a really big cat. Oh, that's a good question from Dylan, who says, just watched Scanlime 21 last night and it was awesome. Will I get more out of it if I watch the live source material? More along the lines of the tools and theory used to reverse engineer the software and how you're able to dump it or unencrypt it? You could. I mean, I definitely went into a lot of detail in the live streams that I had to cut for time. I tried to keep all the important bits and steps in the edit, but you may have to watch it slowed down or like pause it a lot to see what the specific procedure was. It would be nice to have more automated cross-referencing, like, you know, what if I had a tool where I could just give it all my edit files and you could stop the final episode at any point and see, like, well, where did this come from? Get a link to the original stream. That would be great. I think the main limitation there is that I still have enough problems on my own just getting all the footage synchronized for editing that I think to do something like that reliably, I need something approaching kind of a time code set up around here. Oh. Oh, Tuco. Oh, jeez, Tuco, that looked painful. Oh, honey. Whoa. He's really good at the opportunistic catch and grab. Just anytime it comes by, he'll try to just grab it. Oh. I also really like just kind of stalking around the entire shop, because he and I both really enjoy that. It's just kind of hard to keep the camera on it. So, kind of playing in a smaller area. Nice catch. Oh yeah, Jarrett says he is pretty sizable. How much does Tuco weigh anyway? I think last time I weighed him, he was like 12 pounds. Yeah, he's a pretty heavy kitty. I've been putting him on a bit of a diet lately to try to cut down on just how much food he's eating, because I think he has been getting a little bit chubby around the middle. But he's also just got a lot of muscle weight. I think a lot of that just comes from his breed and the way he's built. He's a pretty fast little guy, and he loves running and jumping. So, let's get back to work here. Hello, everyone. I think I need the camera. Welcome back to the camera's viewfinder. Alright, my desk is currently a mess of hardware right now, and I usually don't keep the coffee there, so that's making me nervous. Alright, this is the agenda that I had set aside for today's stream. So, that's FC mod, Fade Candy mod. We'll take a look at that in a sec. I needed a level shifter, and I had some broken fade candies that I'm going to use as level shifters. And then I think actually on the firmware front, I've got pretty much everything I need for the flyer, if not actually everything. So the flyer firmware, I think we're just down to testing it and making sure that it operates as we expect. And then the winch still needs some important components. I think the next challenge that I decided to pick out for the winch firmware was to make a driver for this HX711 A to D converter chip that's used for the strain gauge for measuring force. And that one's a little weird because you need to give it a specific number of pulses, and it actually counts the pulses in order to set its mode. So I might have to do something weird where I do like a 16-bit wide transfer and then do like a shorter transfer after that, and it's probably fine. It's probably just going to be a little bit of extra complexity to deal with. Good morning, everyone. So yeah, this is looking like a bit of a mess. I'm starting to really look forward to having the flyer enclosure designed so I can start to put this stuff into a robot. So I've been also starting to go back to the CAD some more and trying to figure out what's the next question I need to answer in order to figure out what shape this thing has. I guess the last decision I made there was I decided to make the thing actually taller than I'd been previously thinking, because having the winch cables attach at a point that's actually somewhat higher up than the camera will let me kind of lower the camera into more of the workspace here without the cables kind of cutting into like the rack and people's heads and stuff. So having this flyer built on kind of a vertical pole seemed like a good idea. And so it seemed to make sense to build that out of a carbon fiber rod, or a carbon fiber tube rather. So I picked up some small carbon fiber tubes, and I think I'll probably just make it the length of one of the tubes that I got in this 2-pack, which is a 1/2 meter. But I could also make it a meter. That might be a little too big. But anyway, there's a lot of design to think about, which we might do a little bit later. But first I just wanted to stick on with trying to make sure all the firmware on the flyer actually works. It's got a bunch of sensors to read. One of the sensors is on my other desk. I was measuring this to work on some CAD. So yeah, that one that I just plugged in is a motion sensor, which will tell me kind of roughly if people or animals or other radar reflective objects, including probably the environment as a whole, are moving relative to the robot. So it might have a lot of false triggering as this thing moves around, but it was an easy sensor to throw in, and it seemed like it might be useful for kind of having this thing, dim the lights when nobody is near it, or detecting, somebody sneaking up behind it, or it seemed like something that would be interesting to experiment with. So that's on there. It just sends out, I think it sends out pulses at around 10 gigahertz, and then measures small differences in the Doppler related phase shift as they come back. And then it gives me a low frequency square wave that's proportional to that phase shift. And then on the microcontroller, I'm counting those pulses. So that one's just kind of, for fun. It was one of those sensors that was easy to throw on there. There's also going to be a ring of these analog distance sensors, and that's going to be kind of the primary way that I'm planning on keeping this thing from bumping into nearby objects. So those will be somewhat higher up on this pole, looking down at the gimbal to detect objects that are nearby. And those just give me a voltage. I have those fed into 8 analog to digital inputs on the micro, just having those sampled. Then I've got an IMU. So on the last stream, I was having some trouble with the IMU. Some of that was related to a lot of your typical I2C bus problems. I think I was having one problem that was related to kind of an unwanted level shifter, and so I solved that just by giving both sides of the level shifter the same power supply voltage. And another problem was related to the bus sometimes latching up due to the bus state being low when I was initializing the hardware, and so I fixed that with a little software hack that just drives the bus high before turning on the I2C controller. And then, what else? I switched back and forth between a couple of different IMU chips. I had this Bosch BNO 055 kicking around from a previous project. This is kind of convenient because it has an accelerometer, gyro, and magnetometer built in, and it has a sensor fusion algorithm running on a little microcontroller. All of that just with a simple I2C interface. So it's very easy to use. It's also kind of nice if you're planning on, so the alternative to this would be to use one of these other sensors, which I have a bunch of because I found a pile of them cheap on eBay, and so I replenished my stock of IMUs with them. And so these are, it turns out, the MPU 9250 from InventSense. And so this is kind of a weird part. It's one package that includes an InventSys chip that has accelerometer, gyro, and kind of a motion coprocessor on it. And then in the same package, they include a magnetometer. But then the support for it is kind of fractured. And so you can just use those as separate sensors and read them all individually, which is fine. There's a motion coprocessor, which theoretically you can program to do fusion between all the sensors. But the binary blobs that I've seen released for that processor, which you have to load in over I2C, only support the sensors that are on the same die. So they don't support the magnetometer, which is in the package, but on a different physical chip. So anyway, the long short of it is it would be possible to program one of these to perform very similarly to the BNO 055. I just don't have the code to do that. And without that code, you could run the sensor fusion on your own processor. So I could easily run the sensor fusion on this TI processor. It would just be more stuff to deal with, and it would be a lot less convenient than if I had the results already cooked in the format that I want. So that would be doable, but less convenient. And I definitely wouldn't want to do them on the other side of my network link, because any kind of rate mismatch or packet loss, but mostly rate mismatch is what I'm worried about, is going to cause extra jitter and latency between the sensors and the sensor fusion algorithm, which might not be a problem, but it's a lot of opportunity to introduce additional bugs or performance degradation, so it just kind of complicates the situation. So having a sensor that just does everything on board was nice, and yeah, the other problems turned out to be just kind of more generic I2C issues. This sensor does do some pretty extreme I2C clock stretching, where it slows down the bus to say, wait, I'm not done yet. But that's fine. The master on here handles it all right. It just means that sometimes I can't actually update it at 250 hertz. So what else? We've got the LiDAR sensors. I'm going to have 4 of those, 3 pointed at the ground and then 1 pointed ahead where the camera's aiming. And that's kind of overkill. It's just I had 4 sensors, so I might as well use them, and that'll help me deal with additional occlusion from the ground-facing sensors. And so the ground-facing sensors are going to be used to calculate how high above the ground it is, for kind of holding a steady height, and for, again, preventing it from crashing into things. And then the sensor attached to the camera is going to be used mostly for focus. So that's pretty much all working. The last thing that I had added to the firmware that I hadn't really had a chance to test was a driver for APA 102 LED strips. So my idea there was I wanted a couple of LEDs on the top of the Flyer robot for computer vision purposes, so I could set those to specific colors and then use those to identify where the bot is, and then maybe alternate colors every couple of frames to help the algorithm lock on if it's having trouble. That's something which I'm going to add a little bit of support for now, but I'm not going to really overthink it right now because I think I'm going to try to put off some of that design until later. But I wanted at least some allowance for those LEDs on top. I could use IR LEDs, but then I think I might as well just use a visible camera for this. I'm going to have a lot of other stuff going on with IR. And then I also just wanted some LEDs for kind of aesthetic purposes, so I can illuminate, like, oh, the camera's looking in this direction, so maybe I have, like, you know, like a bright spot pointed in that direction on kind of a ring around the top of the gimbal. Maybe I have some other lights just along the pole, so generally just kind of decoration, and plus kind of making it broadcast a little bit more loudly into the environment what it's doing or what its intentions are, that kind of thing. So that's pretty straightforward. I just wrote a little driver that takes UDP packets and DMAs them out, well, writes them to a frame buffer and then DMAs that frame buffer out over SPI. But I was having trouble testing it because, as far as I can tell, the APA 102s are really picky about having actual 5-volt input signals. And a lot of the tricks that usually work with WS2812s don't really work. Like, you can't just like lower the voltage on the whole LED strip and have it change the logic threshold, apparently. And digging around in my junk drawers, I was actually low on plain old level shifters. But I did have some Fade Candy carcasses. So some of these are just devices from my original prototype run where they didn't really quite work out, and so I had to they were in my like bin of stuff to rework. Where did my microscope go? And so here, actually, I'm just going to use this as pretty much a breakout board for a 74 HCT 245 chip. Alfie says airplane-style strobe ring. Not quite sure what that means. I thought airplanes had like red and blue lights on the wings. I don't know what a strobe ring would be. So anyway, my plan here, I have the usual headers here. This is a board I designed a while ago for doing kind of really easy to use LED control. And it's very specific. It's just for if you want to run WS2812 NeoPixel LEDs off of USB. That's the only thing it does. It's just pick one thing, do it well. And this was my original board with the swoopy traces and all. And so I have a few of these in various stages of assembly and disassembly. And this was one that was already missing its microcontroller in my junk bin. So I'm going to assume the 245 chip on it is still all right. But my plan here, I have this header populated. I also soldered some headers to the hacker port on the back. And you'll notice this breaks out the debug JTAG. I'm just going to take these 4 pins and bridge them over to the inputs to the 245 chip just by going from these pins over here to these pins over there with magnet wire. And then I'll have a little board I can use to drive these LEDs for testing. And I can always make some other kind of board for the actual robot if I want. I could keep using this, but at the very least this will be useful for testing. Let's get this plugged into something. Oh, nice. Kevin says, hello from Australia. Well, nice to see someone from the other half of the globe. It's pretty nice. I mean, pretty much anybody could be from the other half of the globe, depending on where you choose to draw the halves, but the equator seems like if you're just going to open the Earth like an egg, it would probably come apart at the equator, right? That's why they draw the line on the globe that way. I'm going to switch to the tiny soldering iron. Okay, so this is pretty straightforward. I checked this with the multimeter earlier, and so I'm hoping I remember this correctly, but I think we're just going to go from basically these 4 pins that break out to the vias here. Those are all debug pins, and we're just going to wire those to pretty much, arbitrary pins over here, but I guess we might as well start at the top. And then that should give us 5 volt, nicely level shifted and strongly driven and well terminated outputs over here ready to go into our LED strip. And I only really need to do 2 of these, but it's easy to do 4, so I might as well just do 4. Now I'm just deciding what kind of wire to use. I could use uninsulated wire for this, but I think I want to use insulated magnet wire. I usually have a spool of that on my desk right here. Alright. This is the usual stuff that I use for surface mount rework. I got a giant spool of this a long time ago, and I'm still working my way through it. Oh, 2 goes on the rack. He likes this mouse. Oh, now he's purring. Oh, okay, Alfie is explaining the airplane lights. So they're saying plane... I think Tuco and I are both startled by somebody dropping something outside. They're saying planes have 2 sets of nav lights, red/green on port/starboard for negotiating right-of-way, and a set of strobes that flash once every few seconds to let other pilots know where the plane is in low visibility positions. Oh, so that's like when you see those like movies about like pilots in really foggy conditions and they're just like blinking outside all the time. Gotcha. Yeah, I think it would definitely be nice to have some kind of lighting pattern in a ring that can shift around depending on the orientation of the camera. So I've got a strip of these 144 LED per meter dot star LEDs, the APA 102s. And so I think that'll be really nice to use for kind of a navigation ring. And that'll probably be something that I put at the lower end of that carbon fiber tube, so near the gimbal. There's an urge in me to make the lower end of the tube super minimal because it kind of can be. So like I could take the PCB mount bracket off the gimbal, I can make my own super minimal connector between the gimbal itself and the carbon fiber, I could run all the wires through the tube. But that gets annoying really fast, especially when it comes to running the coax through the tube, because the tube isn't too narrow to fit any of the normal coax connectors. Aw. Maybe Tuca can lounge up there while I drink my coffee. First he's gonna shred that poor mouse. Oh, and thanks for the links, Peter. Peter's posted some links to PDFs of this circuit board that I'm hacking up a little bit. The good old Fade Candy. Oh yeah, and the good old Fade Candy Rev A, which is not one that a lot of people have. When I had just designed this thing, this was the board that I had like a backpack full of them, and I remember like meeting people at like electronics meetups at bars and like giving people boards out of my backpack, like, here, try this for the LEDs. Is this what you want, Tico? Is that what you wanted? He was about to hop off there to look for this mouse, but I think I got it for him. Oh, maybe you were about to get off for other reasons. I get the picture, Tuco. Oh man, we're never gonna get any work done at this rate. Never gonna get any work done. Because every time I accidentally switch to the cat camera, full screen, there goes the rest of the day. Anyway, this is the wire. Oh, thank you. Comment from Gloria in chat who says, your Tuco Cam series has been awesome, especially your sliced and diced edits. Thank you. Well, thanks so much. I'm glad you appreciate them. I certainly enjoy doing the edits that way. This is an old purchase from OEM wire. Quarter pound of 32 gauge wire will go a long way. Just tear off a hunk of that. What do you want, Tuco? The usual? You wanna play with something? Do you wanna play with the bolt, Tuco? What's up? What's up? Where's the bolt? How about this one? I don't think that was the kind you liked. Oh, do you want to play with this, Tuco? Hey, Tuco, what about a bolt? You want a bolt? You're not going to abandon your freshly grabbed feather to get a bolt, huh? What about chasing the feather too? Oh, you're not gonna let this one get back away. He just like dives for it and then shreds it. Oh, wow. This feather is looking pretty bad. It's seen better days. He seems to like pouncing to find it behind this pile of pillows. See, I don't know how to make something like this more like stream interactive. Like I'm imagining like once TucoCam is working, you'll have people moving the camera around, but like what if someone wanted to have an interaction like this with Tuco over the internet? Like how would that even happen? The bolt thrower seems pretty easy by comparison. I mean, you could make like a little mechanical thing that just like dangles it randomly, but that's not really what's going on. And it'd be really nice to have something where you could kind of interactively move it around. That just requires yet another robotics platform, and then this one seems like it would have a lot more danger of hurting Tuco if it wasn't done just right. What a tiger. Maybe leave him alone with that for a bit. All right. So we need some pieces that are pretty short. I'm just going to cut some that are a little longer than I need, just that I can have them all nearby, and tin one end. And I can just attach all of the ends to one side and then cut them exactly to length and tin the other sides, and I think that'll be a little faster. Just cutting some small pieces off of my giant like 8-inch piece of magnet wire. Alright, just gonna tin one end. Jeez, there's so much stuff on this desk right now. This is partly why I'm trying to get the flyer done with. I want to start getting the flyer more assembled so that I can have more room to make a mess with the winches again. I mean, I could just move this mess, but there's only a certain amount of total mess I want in my shop. This is really low on flux right now. Wow. Sponge is dry. My other solder station has a brass sponge, but for some reason the micro solder station, which is the one that's actually handy right now, has the regular kind. It's like a little weird to need so explicitly just a 3 volt to 5 volt level shifter. And I was looking to see if there was a simple, like, I just want a cheap level shifter shipped to me like tomorrow. And you kind of can, but the ones that I saw were pretty overpriced. And really the thing that I actually want is just this particular chip. So this was the easy way to get a breakout quickly. And this is just a buffer chip. The important thing is the 74 HCT logic family is what makes it work so well as a level shifter in this case. The inputs are totally compatible with the 3 volt logic, and it will drive 5 volts with a decent amount of current, and it goes all the way rail to rail. Huh. Oh, I thought that came off, but I'm going to need to take that off. Okay, I have 4 little tiny tinned wires. I'm going to add a little flux to this board and then solder them where they go on the right side. I'm like, is Tuco somewhere where he can be on camera, in frame, but he's wandering. I'm really looking forward to having this gimbal programmed to do like sparse optical flow tracking. So that, I mean, I think what I'd really like to do is have a way of using chat to command it to, you know, to look at a particular thing or move relative to itself, like kind of WASD kind of controls. But that it's kind of in between commands, the way it stabilizes itself is primarily by, you know, keeping a particular target stabilized in the camera. Just by, you know, looking for corners or looking for other features that are easily optically tracked. It doesn't feel super solid. I'm just having a little bit of trouble getting it what is wrong? Do I just not have enough flux? I'm not holding it steady enough. of crusty solder on the iron probably isn't helping. Let's clean the iron and... why is the iron... I have to like switch hands and reach all the way across the desk to clean the iron. That's not quite ergonomic. Okay, that's better. Let's also use tweezers that aren't bent. I think that might help. Yeah. Yeah, I think maybe... well, part of the reason I'm having trouble positioning these right now is the wire is so long that there isn't really a good way to rest it. And I'm running through a few different ways of stabilizing this in my head. You know, one way to do it would be to kind of tack these down and then add a little bit of Kapton tape or something else, some other adhesive, kind of roughly where the tweezers are, to try to help tack them down while I then solder them a second time. I think that might be unnecessary though. See, that's fine. I think that second one just doesn't quite have enough solder. But I can touch that up after I cut it to length, I think. Bunch of weird noises outside. I can't tell how much of that is like construction and how much of it's just like the usual weird noises around here. That one also might be a little on the weak side. Oh, that particular weird noise was Tuco climbing around behind me. Oops. Well, great. Let's just add a little bit here and then add a little bit of flux and then redo that slightly. Let's improve this situation a little bit. Oh man, this flux is cold. A little bit over there too. That was probably too much. Okay, can I move that soldering iron to my right hand? Maybe I'll just put it right in the middle of the desk because that's slightly more convenient than where it was. This is almost empty. Yes, I hear you. Well, maybe that's not convenient either. Ooh, that's much better. Alright, more flux definitely helped, and I think a little more solder probably helped also. And yeah, the flux, the solder, the tweezers that aren't bent, yeah, several things helped with that experience. I'm getting another grip on the wire kind of from the top so that I can push it all the way down onto the board. And that's something else that this tweezer is doing successfully, whereas I wasn't really getting the other tweezer to cooperate with. And then when there's enough flux, the solder will just flow onto the whole joint nicely. That's what I was looking for. The solder stand is still way over here. Alright, and then let's get these roughly in position. That could use to be a little sharper. Gotta keep in mind where all the on-screen displays are when I'm looking down here at this monitor that doesn't have them. I mean, I'm capturing this feed, but it's also nice for the the broadcast to have things framed all right. All right, so I want these lifted off a little bit so I can tin them. Fluxy. Oh, Tuke's back on the rack. Tuco sure is backlit. Okay, sticking that to the board was not intentional. But that gets the job done. I'll just have to take it off now with a braid. Or maybe with gravity. No, I guess I'll need braid. This is the skinniest braid. Okay. Is that what I wanted? I think that's one below where I wanted it to go. Oh man, flux is really good for soldering, but just as a substance, it's pretty bad. It's just so sticky and unpleasant. Okay. Ew, look at all that gross stickiness on my tweezers. It's like, no, really, this stuff is super visually unpleasant. I want you all to look at it. Cleaning my tweezers slightly. I know that isn't actually on camera. Brush. I think the carbon brush is pretty much the only tool that works for this. Q-tip kind of works, but can't really get in between these little spaces. And the anti-static brushes specifically are nice for the electronics. I need a little more solvent for that. Probably be testing continuity before cleaning it. I just got a little carried away because of how much gross flux there was on this thing. probably use a toothbrush for this too. I wonder how much static electricity you can generate with a toothbrush. This is no clean flux, which means you don't have to clean it off the board. It just makes the whole thing less unpleasant to deal with if there's less flux on it. Alright, let's test this with the meter. Is that brush actually gigantic? This is the brush. It's not very gigantic. But there it is on the microscope with a cat hair for scale. And this fade candy is even smaller than the ones that Adafruit sells now. The Rev A was a little bit littler. It was embiggened slightly for the new Rev, mostly because I had to use the mini USB instead of the micro. So, probe clock down here. That second input. Third input. No, it wasn't in focus for me either. Cool. That is the expected behavior. So we should have now a little jumper wire friendly 5-volt level shifter we can use to test out the LEDs. Let's boot up the O-scope. And let's hook this whole thing up. Oh yeah, Robert says even no clean flux can affect sensitive high impedance analog circuits. Yeah, for sure. Some of the most sensitive stuff, you can't even have solder mask on the board. But yeah, any kind of contaminants can affect some kinds of circuits. The no clean moniker is mostly because it won't like just dissolve your board if you leave it on there. So there's our modified fade candy based level shifter apparatus. We could still apply power with the USB port, but I also broke out the VUSB down here. So we have 2 grounds. We have, I think I'm missing a power to power this with. Yeah, so if we want 5 volts, that would be here. It is on right now, as you can probably see if you saw the lights. It's drawing like 300 milliamps. I think a lot of that is the LiDARs. In fact, the LiDARs draw a lot of power when they're on, even when they're not taking measurements. So I think a lot of that is going into the FPGA in there and not the laser. So let's just check the voltage. We have? 4.7 volts. I guess that'll pass for 5. One thing that is kind of interesting about the Fade Candy circuit is it includes a little 5-volt booster that'll take the not quite 5 that you're probably getting from the USB port and boost it up to actually 5 for the outputs. Which is kind of superfluous for the circuit because we're not dealing with super long wires, but might be handy. So there's the partial Fade Candy down there. And forget which of these is clock and which is data, but we're going to look at them on the scope in just a sec anyway, so let's just plug them both in. Alright, so next step, we have to send it some data. I don't have it just spamming out frames to the LEDs continuously. Instead, I just have it doing it right after a UDP packet comes in. So here it's running, that's data from these proximity oh, you can't see that because the grabber is frozen. Come back, little grabber. Oh yeah, Vince has a good question asking about recommendations for mixed voltage logic level translators. I don't know any off the top of my head. I know I've seen a good selection of different breakout boards by folks like Adafruit and SparkFun. I think Adafruit in particular had one that was pretty cool. I forget which chip it was based on. Some of the really nice ones that do kind of the seamless bidirectional logic level stuff also don't work super well with fast signals, but there might be some good parts out there that are a compromise between those two. I just don't know numbers off the top of my head. Haven't had to buy one of those recently. Alright, so let's stop receiving telemetry here and instead let's spam out some frames. Yeah, so I have a little, oops. Yeah, this UDP poke script that just spams out packets. And in this case, I'm going to send 1 pixel of bright white every 100 times a second, so every 10 milliseconds. So if I have that running, you should be able to see those signals coming out of the driver on this little microcontroller. Let's get a better connection to that. That isn't right. Oh, 10 kilohertz. Right. I had some debugging stuff in here. I wanted to see if it would work with this super low frequency, but I think I just need to revert that. Oh. Let's save that for later. I was working on starting out the HX711 driver. So right now the state of the LED driver, I expect it to have a 10 megahertz clock. Yeah, 10 megahertz, 200 pixels, which is mostly me being lazy and trying to fit the entire frame buffer into one micro DMA transaction. It's a very simple driver. I have it initializing all the hardware we're using. So that's hardware SPI, DMA, and then I'm just doing a straightforward software copy of the packets into memory so that I can release the LWIP buffer quickly. So that's not optimal, but should be fine for what we're doing. And then the actual SPI transfer is handled entirely by the DMA engine. So let's rebuild that. We want 10 megahertz, not 10 kilohertz. I think right now it's just never finishing. I'm sure the DMA engine doesn't like being forcibly restarted like that either. Okay. That's better. Alright, so that's my 10 megahertz clock. Three-volt logic. Great. So while I have this probe, this is just the yellow probe. I'm going to check the power on here. So this is the input. So is that like 4.8 volts according to the oscope? And then that's the power going out to the driver chip, so that's like 5.1 volts. I have a noisy ground, but it's fine. That's the data coming out of the level shifter, and that's the clock coming out of the level shifter. So great. Let's actually look at those both on the scope just for completeness. It's a slightly better ground. Some people ask why the fade candy has so many grounds. It's because you always need more grounds. So it has one per output channel and then just a couple of extras. Alright, so here's the output of me using this TI board to generate the SPI from the signal that's ultimately just coming out of the Raspberry Pi, and then I'm using this hacked up fade candy board just as a level shifter. Nice edges. So let's see if we can actually drive the LEDs now, or if there's another problem. I think my example might be pushing the limits of how fast this can go too. Which reminds me, maybe I want to write this driver so that if you get a new chunk of data while it's already writing, that it just asks to start again later. Let's try doing that really quickly. So we're just going to keep track of whether we need to do another write. Oh, I didn't even bother setting up a completion interrupt for this. I think just for simplicity, I'm going to have this ignore writes if they come in while we're already flushing. So we'll just have LED write busy. Oh, even that's going to require the IRQ though. Okay, I'll put this off for later. We're just going to make a small cleanup so that if the data comes in faster than we're flushing it out, this won't potentially do something unintended with the hardware, but I think for now I'm going to ignore that problem and just send out data a little slower. Oh, you know, maybe we're seeing... It looks like maybe the SPI peripheral is going into a high impedance mode after we're done with the packet. That's interesting. I guess that's what I was seeing earlier. Yeah, I mean the packet clocks out so fast that I can send them every 2 milliseconds. So yeah, I'm not going to worry about pending writes. This is all very speedy. Anyway, let's plug this into the LEDs and see what we can do. Alright, these are the nice and dense ones. 144 LEDs per meter. So this is the output end. I'm just going to put, I'm actually just going to cut the stripped region off of these so I don't short out these wires. This over here. And the input end. Okay. So this was data and then clock, I think, which... I'm going to use one of these long headers. And then... these jumper wires. So this will be ground. And I think this was data and this was clock. Here, clock is closest to ground. Data's next. Oh, we're already getting a little bit of LED onness just from parasitic power, which is probably not amazing, but that's happening. Let's give this thing some actual power. Okay, so this is currently not on, but it's going to be 5 volts. And I'm expecting to see all of these off except for the first LED, which should be all the way on, I think. Yeah, first LED should be on all the way. Well, it doesn't immediately work. Maybe I have the clock and data backwards. Just drawing an appropriate amount of current. Now it's all on. Let's take a look at this on the scope. Oh, what's going on there? A lot of noise. Is that just clock noise? Probably. Anyway, that's my data. And that's my clock. That seems right at first. Maybe I'm doing something wrong protocol-wise. Let's get this on the scope. More of this needs to be taped down to the desk. Okay, so that should be the SPI signal we're sending to the APA 102s, which are currently off. We have 32 zeros, then 32 Fs, then a whole load of zeros, and then some Fs at the end as padding, but it doesn't really matter what those are. Just, if we turn this on, we were seeing before, oh, it is on. So with it off, we can see it kind of driving against the unpowered rails of the LEDs. Then we turn the LEDs on, we get the same wave. And no output. Oh no, we're getting an LED now. That's what we wanted. Did it fix just by power cycling the LEDs somehow? Let's see if it's actually working or if this is just a coincidence. I might not be doing the gap between frames properly. Like, it looks like my data might be in an undefined state. Maybe it needs the data to stay high. Okay, let's try sending these packets with 0. No, it's not shutting on. This is looking like a problem with the gap between frames. Like, let's try a different test, like maybe zeros and then the second pixel on. And then, while I'm sending this, power cycle the LEDs and see if I can reproduce the behavior where the second one's lit. No, now the first one's lit. I think maybe the protocol is not right. What am I doing wrong here? I mean, it's pretty light on the info here. Oh geez, is there something crazy going on in the YouTube chat over here? Oh, go away. Yeah. Yes. I'm using the right polarity here, right? Oh no, wait, this one shows the clock being low between frames. Is that what I'm doing wrong? From this data sheet, it looked like we were dealing with a clock that's idle high, but maybe I missed something. That's what happens when I type off screen. Yeah, somebody else talking about the end frame issue. I don't think that's what we're dealing with here. I've been really close to just grabbing some Arduino sketch library and trying that just to look at it on the scope and see what it's doing, because I just don't see anybody documenting what the actual state needs to be between frames. Useful. Idle state is low. So that's probably what we're not doing right. It must have just a separate circuit that detects the boundary between frames, just with like an RC timer looking at the clock. So I think that makes this SPI mode 0. Let's try that. As opposed to mode 3. Recompile. Recompile. Always gotta recompile. I should go back to the tiny throwaway password instead of the long throwaway password. Programming. Okay. So now we have idle state low, little bursts of 8 bits. Alright. The LED is still not quite doing what I expect. Is it responding at all? Whoa. What key is stuck down? Is that right? That looks right. I could try slowing down the clock. I thought these were supposed to work up to like 32 megahertz. Not a lot of timing diagrams in there. Oh, here it is. This is the same one from before that doesn't even show the idle state correctly. Does this even rate the clock frequency? Don't see a clock frequency rating. They just suggest using the fastest speed. Huh. Well, that was fun. Wasn't what I wanted. Let's just try a lower clock frequency. Down to 1 megahertz maybe. Hey, Tuco. That should be a little slower, maybe. Did Tuco bump that control? We've still got our blue LEDs. Is it possible I've still got clock and data backwards or something stupid like that? Mode. So these are supposed to be pixels. My intention is for these to be pixels over here on the oscope. Well, I've got something when I swap those. It's not right. My terminal is made of beach balls. Why? Oh, dude, really? Why is my terminal made of beach balls? I think the clock and data were the right way around the first time. Well, maybe let's try this on an Arduino, just to have a reference that works. Good old 5-volt Arduino or something. Let's see what I've got. Alright, I have an Arduino Uno, which should be pretty classic. Let's find the sketch we can use with this. Yeah, let's go to this screen for a little while. Robert says the spikes don't look great. Can you reduce the drive strength? These aren't being driven by the microcontroller. These are being driven by the... unless you're talking about some pins that I haven't been looking at recently. These are coming through my 5-volt level shifter. And I do have series termination resistors. They might not be the optimal values, but I doubt that's where the problem's coming from. Let's just install this library. Oh, that's right. I can install the library through here. Uno. We've got to try the rainbow example, right? Pins 11 and 12. Let's try this. Plugging in my Arduino Uno. Does this need external power? I think it does. Why does this need external power? Be sure this needs external power? I think it does. Okay. Do we have VN on here? Yeah. Long headers. Alright, I guess I'll steal power from this board. Alright. I think my Arduino is on. Might just be having USB problems. Ah, yeah, maybe I was just having USB problems. Try this again. What is that junk on my O-scope? Not that I'm using that right now, but... Oh, that's because my grounds came undone. I'm not actually using that right now anyway. Okay, I think the Arduino's on. Why isn't it showing up in here? Let's try a different cable. This also might be an Arduino with a USB problem. Let me try this on a different computer, maybe? Or... no serial ports. Yeah, maybe that's a bad Arduino. Maybe, I don't know why I would have a broken Arduino. Okay, well, what else do I have? Here's another Arduino Uno. It's certainly possible one of those was something somebody gave me at one point to fix, and then I forgot it was broken and it got mixed in with my other microcontrollers. Oh, that one seems more alive. Let's try plugging that into the other computer. Arduino Uno, great. Alright, maybe let's just look at this on the scope first. What pins are this using? 11 and 12? On ground. So that's 11. This also seems to have a whole bunch of ringing. Look at that overshoot, but strong signal at least. So idle low. This time it's idling with both clock and data low, which might be important. What about the rate? Is that kilohertz? 75 kilohertz? That couldn't possibly be the maximum. But let's just try hooking these up to the LEDs. So, another little bit of this stuff. I've been using yellow for clock and blue for data for some reason. Alright, good old 5-volt outputs from the Arduino. Ground. Clock. Data. Ooh, those are warm. And now I've got something that does not seem very rainbow-like. Maybe these are backwards still. Let's actually probe it, maybe. Never enough grounds. There's clock. There's data. Still not much. Just try recycling the power. It's also possible these LEDs are bad, and I could try a different strip. Or try cutting off the first LED from this strip. And they come back drawing 170 milliamps total and not displaying anything. Yeah, well, let's try another LED strip then. Start trying to eliminate the potential problems. Oh, I can also take a coffee break. This one then. This is the input side. Oh, this one has clock and data the opposite direction from what I'm used to. That's interesting. This one has data next to ground instead of clock. I thought I tried swapping all of them that I've been testing so far, though. So this one. The other denser one, the 144 LED per meter, wasn't actually labeled, whereas this one has room for silkscreen markings. So let's try swapping these. And powering them. That looks better. That looks like a rainbow fade. Okay, that's a good data point. We have something that works. So let's go back to the denser ones and try both polarities, and if that still doesn't work, I'm just going to chop off the first LED and assume maybe that one's broken. Because I would like to be able to use this denser stuff, but I mean, I'm not going to use it in the waterproof casing. I just want the denser LEDs. So yeah, that seems fine so far. Okay, denser stuff. Right, so input side, again, our old friend. So let's try plugging these in the same way as that strip we were just using that had data next to ground. I don't know if that's going to be right. Okay, now the whole thing is flickering a little bit. Could it just be I had clock and data backwards, and maybe it has trouble recovering from that without a long power down? No, that still seems incorrect. Oh, it's working up to a point though. Yeah, maybe this strip just has some bad LEDs in it. Because now we're getting rainbows at the beginning. And then the rainbow breaks right here. So, man, I need to stop down the camera a little bit to get all this dynamic range. Anyway, I'm not going to bother photographing this mess too much, but I'm just going to assume that this particular LED strip might not be perfect, but at least the beginning of it seems to work all right. So let's try to transfer what we've got working back to the actual bot firmware. I'm definitely going to be taking this strip apart and just using pieces of it. So I'm pretty sure the problem isn't going to be at the like byte level. I think it's going to be in terms of like the idle state is not something it likes, or like the data rate is something wrong. I think it's going to be something at a lower level than just looking at the bytes that it's sending. But there's always opportunities for the problems to not be what I expect them to be. So yeah, let's just try plugging my controller back in. So this should still have power. Do we still have bits coming out of this? So I want ground, and then data, and then clock, it looks like. So let's swap these. And then what am I sending out right now? I'm sending out a bunch of nothing. Let's send out my one frame of something. Seems fine so far. So what I would expect is when I plug this in, the rainbow disappears and it's replaced with one white pixel and then a bunch of blackness. Just not that. Not quite that. Okay, so what are we doing differently? Is this the idle state? Is it something more complicated? This is the Arduino's output. Oh, I've got these backwards on the scope. This is not going to be the best grounding. So everything idles off. This data rate is really low. Why does it think that's a 0? Ah, this timeout is too low. Okay, so in this case you can see a bunch of zeros. So 4 zeros is the header, then each subsequent group of 4 bytes is a single LED. So the E1 is a brightness, and then red, green, and blue. Do we need to just send this super slow, or is it the idle state? Those are both essentials. And then what do we have coming out of my controller? Ding, ding, ding. Oh, good question, good call. Nicole in chat asks for an update on what we're seeing for anybody who's new here. Yeah, so I'm just debugging. It's debugging firmware. I'm really close to, I think, being pretty much done with the firmware for the flying part of the robot. And the firmwares in this project are all pretty simple. They're just basically just reading sensors. In the case of the winch bot, it'll be doing a little bit of local motion control. But the firmwares are going to be as simple as they can be, with most of the work being done by a PC. And so this is for the project that follows around my cat with a camera, and so the PC is going to be doing computer vision and streaming and other stuff that requires processing on the video. But then all of these little microcontrollers will just be reading sensors and controlling motors and talking to the gimbal. And in this case, I'm just adding like the last feature for the flying robot that I need right now, which was just controlling some onboard LEDs, which are partly just for some visual bling, partly for navigation, partly for just kind of interacting with its environment. And so they're just basic APA 102 LEDs, but just going through all the, reinventing one of the typical wheels here and making an LED driver. So mine's idling low, just like the other one. The biggest difference here is that my data rate is way faster because I'm sending out at 1 megahertz, whereas they were at like 70 kilohertz. But I'd be surprised if that was the only, or if that was the relevant difference, because I thought these were supposed to go way faster. Like, I've heard people say like 16 megahertz works just fine on these. So let's try bumping these drastically down. Let's save these, but let's have 70 kilohertz. And let's only send out like 60 LEDs maybe. So the firmware is really simple. It spams out UDP packets like 250 times a second with sensor readings, and then it also accepts some incoming packets with things like commands to send the gimbal, or in this case, a frame of data to send the LEDs. And so it just starts up a DMA that sends it out over the SPI port. Reprogram. What a good cat. Alright, so this should be back online momentarily. Are you in a reboot loop? I think it's in a reboot loop. Why is it in a reboot loop? Maybe this is too slow and I'm hitting an assert in the library somewhere. Let's see if I can, well, I'm curious. There are a couple of ways to check that theory. I could actually just go in the code for this and look at the assert. I could attach a debugger and figure out why it's restarting. The watchdog makes debugging stuff like this a little bit more annoying. So I could disable the watchdog timer. I could also just try increasing this rate. Can I get away with 100 kilohertz? That's still in a reboot loop. Okay. Oh. There's a prescaler that should give it a decent amount of range. Maybe that's not the problem. Well, we could try turning off the watchdog for debugging purposes. Oh. Now it's up. Maybe it was just taking a while to negotiate the link. Okay, maybe the slow startup was a red herring. Let's put this back to 70. I think there's a lingering bug that sometimes shows up but hasn't been especially, hasn't really been a blocking issue for me, where the watchdog timer, usually it's not supposed to be active until we've successfully started streaming back data, and then it'll just kick in if we ever stop. But I think there might be a bug in that sometimes which prevents startup from succeeding in a timely manner, but eventually lets it succeed. So I think that's just an unrelated bug. So 70 kilohertz. And now we're back to this. Can I speed this up some? Yeah, I've got no link light on the hub, or on the network switch. Maybe this is a logic error in my watchdog code. So the watchdog timer gets enabled right after that UART message goes out. Then we do some more setup. Oh no, the watchdog is down here. So it's after some of the setup, but right before the systic timer turns on. And then we reset it up here. Yeah, so this is called from the systic ISR. And we're taking a look at these link stats in LWIP, and then conditionally resetting the watchdog based on those. So the case that we're supposed to be hitting right now is this thing where if it's never seen a transmit, then it resets the watchdog every systic. It's definitely just a watchdog reset. Let's maybe add some debugging here. Can I print? It's a little dangerous to print here, but let's try anyway. So now I'm changing topics again slightly, and instead of debugging the API 102, I'm debugging the watchdog timer, because I think this bug is reducing my ability to reset reliably. And this is just adding some debugging. So hopefully I'll get some print spam. So we are getting in that timer. This is saying we have seen a transmit. Whereas I don't know if that's actually right. Oh, or is it working now? I think it's actually booted up correctly. So maybe we changed, maybe just by adding that print, we changed the timing enough to hide the bug. If I unplug the network cable, we should see that change, though. Which side do I have reach to? So if we unplug that and then reboot it, oh yeah. So if we unplug it and reboot it, I shouldn't see it transmitting at all because it can't transmit without a link. But we're still seeing some ones there. So I just hit reset, and here you can see it starts out 0, but then it's detecting what it thinks is a transmit. So maybe it's a bug in this logic. It's just checking to see these counters change, and it's also checking to make sure that it's not just, it's kind of discarding the first change, basically. So let's move this debug up here, maybe. Printing out a few different variables here. I find printf debugging to be like almost up there with oscilloscope debugging for stuff like this. Where like you don't want to stop it and then look at the variables. You just want it to print out what's going on as it happens. I'm also going to reset these LEDs because the bright white portions are getting pretty hot. Alright, let's update that. We'll have a different set of 3 numbers. Interesting. I guess this number... Well, what's going on here? It's acting like it has a link, but I don't think it's actually plugged in. Unless I unplugged the wrong cable. No? I think it's just decided that there's a link, even though there isn't one. Which, maybe the link... what's going on now? Okay, well that's weird. So I mean, clearly sometimes it can transmit even when nobody's listening, because I think the link down detection requires some idle time. But I still don't quite understand how that was interfering with my ability to boot before. And without that debug printf, I'm just back here. I think think maybe at this point it would be nice to print this stuff out without affecting my timing so much, so maybe oscope debugging is the next step. That's interesting, and now it's working. You know, it might just be that part of the initialization is taking too long, and so we don't end up getting that very first watchdog hit. Maybe let's clear the watchdog a couple of times during the early initialization just to make sure it's not timing out too quickly. So let's get rid of this. So, part of my strategy here was to initialize the watchdog fairly late on, but that actually doesn't work when you're rebooting the system because you can't turn off the watchdog in software. So it stays on even during the early initialization of the next boot up. So I think it might actually be better to put this really early, like right after the clock is ready. And then we clear it here. We could also maybe clear it right after that UART flush. And then maybe also as we're starting up the LWIP stack, but then after that we should be able to rely on the sysdic interrupt. Oh, maybe that was it. Maybe that was a race condition between the watchdog timer and the startup code. Huh. Alright, well, I'm not sure that's actually completely fixed, but it's fixed enough to debug something else right now. So there's my super slow SPI. Oh, why is it so slow? Let's send these out less frequently. And maybe let's also send out some different packet contents. SK9822. Hmm, 3 bits, 5 bits. I thought I remembered that packet starting with E1, which would be pretty low brightness. Yeah, let's do that also, have pretty low brightness. And then half PWM or something. So that's what we see on the scope. So LEDs are powered. Can we plug them in? That is different. Now the power supply is having trouble again. I mean, not having trouble, but getting louder because of all the power I'm asking for. So that's definitely data and then clock. What else could I be doing differently? That's data. That's clock. Oh, maybe the problem is I have, I've been leaving all the empty pixels set to 0, but maybe that's not actually what these guys want. Maybe they need those upper bits set to FF even for the subsequent pixels. So let's try initializing that, perhaps. This is one of those cases where I would love to just have a 32-bit version of memset. Do we actually have that in newlib? If they're not... W memset. W memset is beach ball. Man, why is terminal beach balling so much? Yeah, that's wchar. Okay, fine. Actually, I should probably turn them all the way off, because that's almost off. That would be 0. Is this gonna matter? Okay, so now we have those high bits set on all the pixels, even the ones we're not using. Does this make a difference? Our LEDs are powered. Oh, that might have been it. Oh man, so maybe the LEDs do actually check for those high bits in the next word as they're kind of doing the internal processing? That's interesting. Can we verify that? I just made a noise that I had to investigate. So E1 FF0000 should be red. Let's just do a little RGB triplet. That works. Well, I guess that was part of the problem. So let's see if we can step up the clock rate now. Can we go back to the 10 megahertz that I wanted? And in that case, let's actually maybe modify this so that we, force the incoming pixel. So I'm thinking maybe a slightly different format for these packets. So this is saying, this is just linearly copying every byte through. I think maybe I want to do the copy 32 bits at a time. Can we rely on this payload to be aligned? I don't think we can. Maybe this is what we want. I just want to OR the high bytes with EO to make sure that they have those bits set. I'm also kind of overthinking this. I mean, I could go through this in a separate step. I'm just not going to worry about it. I'm going to make sure that that is set properly on the transmitting side on the PC software, and I'm not going to worry about it here. Well, that's working. So, I think we should just try writing some more interesting software. Oops. Clear some space here. All right. Okay, so we can put this firmware aside for the moment, and now we're working on Python code on the Raspberry. So that was just using this UDP poke script, which is very basic. Let's try making a little LED tester. And thinking about whether to make that LED command more complicated, because it could certainly take parameters that let you update only part of the array, but I can't think of why I would want to do that. I'll probably just have something spamming out all the LEDs all the time and doing whatever calculation I want every frame. Don't really have a reason not to. So I'm not going to bother binding the socket, probably. I don't really want this to receive anything. I'm just going to have this transmitting. Is there a better way to do this one than struct.pack? Well, let's just do this with struct. So this could be longer than the max LEDs on the device, and it would just end up cutting off the rest of the UDP packet that it's not using. Yeah, and let's actually make these big endian. So that makes a little more sense the way these are being sent. Let's just try making a bunch of grayness. Let's see what that does. That should give me a bunch of really dim gray pixels. Or an error. That's acceptable too. This is just a problem with Sublime Text defaulting to tabs. Cool, gray pixels. Now maybe something more exciting. So let's maybe map something like this. I don't really like this time.sleep because that completely ignores the time it takes to send the packet, but maybe that's fine. I mean, it just goes out on a queue somewhere. It also ignores the time it takes to calculate the packet, which in Python is maybe non-negligible. I think that's what I wanted. So this generates pixels by calling the shader with the current frame number, and then mapping that for all the LEDs. And then all the pixels end up getting packed into big endian integers. We add the header and then send it out over UDP. And then so the shader gets called with a frame number, and then it returns a function that calculates the individual pixels. Oh, a good question from Mikkel. What kind of strip are they, WS or APA? These are APA 102s. I went with those partly because they'd be a little easier to program on this particular micro, and mostly because the higher refresh rate would be better for a robot that's moving around a bunch. But yeah, I don't have quite as much of these. I've got a bunch of the WS2812s because of the Fade Candy work that I did, but I only have a few reels of this stuff handy. So we could do a bunch of different stuff in here. So brightness, let's just set that to something. So this is between 0 and 31. So let's just fill in some default values here, and then we can go in and animate this. Should the LED be returning a byte array, maybe? I don't know, I'm so used to this being an integer kind of thing. I guess it could return bytes. So if I did that, I would get a nice non-animating thing. Just make sure that works. Purple. Why are they purple? That's a nice color, but it wasn't quite what I was aiming for. Brightness works. Oh, missed a character. That's better. Great. Now maybe we can have some fun. We could do a classic rainbow thing. Those are always nice. We could also sample colors from something. Let's just check out the Python color space library. Is that, I thought that was in the standard library. Yeah, color sys. I don't really want to make a rainbow thing though. Let's make some little doodads that race up and down the strip, because those are fun. Maybe the even simpler version of that is a couple of sine waves moving around at different frequencies. So how do we want to do brightness scaling? I'm just wondering how much abstraction to put in here. I just want to try something out. Let's try this first. This will be really dim and not especially interesting. Red, green, and blue are too long to spell out. Red, green, and ruby. I think I'm getting some overflow there. Well, I think that's safe to say that it's working. You can add some different colors and different effects, and I think a lot of the kinds of stuff I'm going to want to do with this involve some of the LEDs being programmed in specific ways, like the ones that I'm using for navigation on top. But then a lot of what I want is probably going to be like taking taking kind of like particle effects, like blobs of light, and kind of moving them around. And like I've got code to do that in the Fade Candy repository written in a few different languages. I usually like to organize it as kind of like a little particle system. So each LED kind of samples its vicinity to see what color it should be. I want to see the high dynamic range on these things work though. And so can we make this even pointier? I want to make this really pointy. What about how pointy does Power 40 look? That's very pointy. Now, what about flip? So this is a number from 0 to 1 that's strongly, well, yeah, it is 0 to 1. I think maybe I want it to go a little higher than that. It's a question of how much saturation I want. Some saturation is usually fine, but let's try doing this without saturation. Let's try linear first. Just scale the brightness the same as everything else and see what happens. I don't think it's going to be as interesting as if we scaled that non-linearly. Oh yeah, that's definitely needs some non-linearness. Yet another power function. We have that move slower. that's better. Oh, and a great question from Mikkel, who asks for a walkthrough of the code, and what the different pieces are doing. Yeah, let's do that. It's kind of smooth. There's a little bit of jerkiness because the frame rate is not especially high right now. Is that what I'm seeing? Maybe that's just my eye moving around back and forth between the dots. We should be at about 60 FIPS right now. Okay. So this is the entire little program that we're dealing with right now. So this is running on a Raspberry Pi that's connected to this microcontroller over here via Ethernet. And this microcontroller is then piping out SPI data to the LED strip. And the microcontroller is one of these TI Tiva-C Launchpad development boards. Basically, it's a $20 board that has Ethernet and a bunch of peripherals. So pretty handy for just gluing stuff together into a network like this. So let's see. So this is just starting out with a few definitions for things that we care about. This is the UDP port that we're using for everything on the robot. So telemetry comes back on that port. We're ignoring that right now. Right now we're just using this port to send commands to the micro. Sodium says, "Whoa, that's much cooler when moving slower." I agree. This is more like what I would want to see on the robot. And like, imagine these. I mean, I'm imagining a couple of different rows of this to create something that's kind of a cylinder that has a little bit of vertical resolution, but is mostly just wrapped around the gimbal mount, and then it can kind of like follow you, kind of like an eye. Oh, and then so John is asking what the Ethernet board was. Yeah, so this is a. Do I have the box for this somewhere? It has a really annoying model number. There it is. It's the Tiva-C series. Oh geez, is that going to focus? The TM4C 1294 Connected Launchpad Evaluation Kit. Yeah, so it's kind of a mouthful, but you can get these for 20 bucks on DigiKey, and there's a lot of different ways to program this. TI has their own IDE called Code Composer Studio, which I find kind of awful, but other people might like it. There's something that's kind of Arduino-like called Energia, which I find awful in completely different ways, but other people might like it. And so far I've been using this, basically a port of their library stack to GCC and Make. So you can just use like standard GCC ARM cross compilers to build stuff for this board. So that's what I've been doing with it, and it's pretty nice. 20 bucks, Ethernet, a lot of peripherals. So, and then this is all the Python code we're running. So the main loop here, so we're invoking the main loop. The main loop is opening a socket. Since this isn't bound to any port, we aren't going to be receiving anything on the socket. We're just using this as a way of transmitting. And we don't even give it an address because we're giving it the address on each packet. We could bind it to this address and then use send instead of send to, but this is a little nicer in this case since we don't have to bind, which means we don't have to kind of take up that port, prevent other programs from using it. And that also means that we could pretty easily make the LEDs run as a separate process if we wanted to, but I think we'll probably want most of the robot control stuff to be in one process, maybe the computer vision stuff to be in a different process. So this enters a main loop, just spamming out packets. It's controlled mostly by this sleep, which causes the loop to run no faster than one packet every 100th of a second. In reality, it'll run a little bit slower than that because this code takes some time to run. And there are a lot of ways we could get around that by measuring how much time has actually elapsed and trying to synchronize to it, but I don't really care that much in this case. So this line is sending out a packet and building up that packet out of a bunch of integers. So the send to is just sending a UDP packet. In this case, this first parameter is the packet itself as a bytes object in Python. And the second parameter is the IP address and port that we're sending it to. So in this case, it's an IP and port that we've kind of hard-coded in the microcontroller's configuration EEPROM. So the port, yeah, that just identifies this particular board and its UDP port that it does everything with. Then this prefix identifies what kind of message it is. So it's just going to be a single byte that just says everything after this is LEDs. It could be gimbal stuff, it could be, you know, controls for the winch, but no, this packet is LEDs and only LEDs. So after that header, we have this struct.pack, which converts a bunch of 32-bit integers in Python to just a buffer full of packed bytes that are in the format that we can send out. In this case, we want big endian, which means that the most significant byte comes first, least significant byte comes last, which is the opposite of what we're using for most of this protocol, but that's how the APA 102, well, the APA 102 doesn't really have an endianness because it's just thinking in terms of bytes, but if you want to represent these pixels such that the brightness is at the high end, and then it goes red, green, with blue at the low end, then it makes sense to think of each pixel as a big endian number. So that's what this is for. And then, so this is just assembling a format string that tells struct, I've got big endian numbers, and then this many integers. So this just creates a string that's like 200 eyes. So that tells it how to encode these pixels. And so at this point, pixels will just be a list of 200 integers that all have brightness, red, green, blue packed in there. And this is just converting those from integers in Python to a byte object in Python, or bytes object. So then making the pixels comes from this line. So we're taking this shader function and calling it per frame. So this is giving it an opportunity to do any per frame calculations that it wants, which in this case we're not doing anything, but we could do anything per frame we want up here. And then it returns a function which then gets invoked once per pixel, given the pixel number. So by calling shader, we're kind of priming it to create a frame for us, and then it gives us a function that we can get each pixel value with. And then map actually evaluates that on each pixel and gives us all the results we want. So I could illustrate that a little bit if we put some prints in here. So that's the frame it's at. And then we can actually see that packet on like TCP dump if we want, but I'm just going to have a copy of this so we can see exactly what's being sent out. Oh. Accidental white space. Oh, did I type something wrong? Oh, by calling this twice, I've exhausted the map object up here. So Python 3 does this thing where when you call a map, instead of actually evaluating it right away, it gives you an object that does the lazy evaluation. In this case, I think it might be easier just to convert that to a list right now. Okay. I'm just going to stop this so we can look at the individual steps here. So we have the beginning of the frame. We're calculating all these pixel values, which would make a little more sense if you were looking at these in hexadecimal. So maybe we'll do that. Yeah, so now you can see the frame number. Then here's all the pixels we're calculating. These are all the ones that are off and just have the kind of framing bits set that all the pixels have to have. These are the ones that are on. And then here's our packet. And it's going to start with that header byte that says the rest of this is LED data. And then every 4 bytes, you'll just see another pixel in big endian order. So that E0 comes first, and then RGB. pretty much it. Let me know if you have any more questions about this. Take out some of this debugging. I was also realizing that maybe, I think that lowest level brightness, I don't know, I think I should be rounding the brightness slightly different. I think we want to mostly round the brightness up, not down. Let's at least round it properly. We might as well round these properly too. Okay, well we could spend a lot of time like just hacking on this and making it do different things visually. Let's at least make the blips different colors. So one thing that would be nice is to be able to have algorithms that calculate red, green, and blue just as floating point numbers or whatever, and then to come up with a brightness scaling that works pretty well for that. Oh, that's a cool idea. From Whisperfist in chat, who says, I can imagine virtual pots of light hanging in the shop, and then Tuco Flyer picks up patches of color as it moves around. That would be pretty cool. Yeah. Okay, well, I'm not going to go too deep into this right now, since I think I need to think about how I want to do that before just kind of flailing at the code. But let's at least check in what we've got, and maybe think about what to do next on this stream, or possibly how to wrap it up. Oh, that's a good suggestion from Sodium, who says, wouldn't mind an explanation of how the pixel value generation code that you've got works, or how you think about it. Sure, we could think about that. What else do I have? So I changed the SPI mode. I have some default filling for the buffer. I have a 5-volt level shifter. I changed how the watchdog works a little bit. All right, well, let's go back to this critter then. So I guess I was thinking about this in a couple of different pieces. We've got the actual, like, combining stuff together into a packet here, which I'm kind of having second thoughts about how this is done, actually. Maybe I just want this to be the shader to return buffers and not have to go through the struct.pack separately. I guess that was partly me thinking like, oh, I don't want to have to call struct.pack separately for every single pixel. That sounds terrible, but I don't think it matters. Anyway, so here I'm just assembling it. Up here, I was trying to keep this to just kind of post-processing stuff, so if you already have a red, green, and blue value which seem kind of perceptually relevant, let's actually, well, I guess this was starting with monochrome value, but I would do the same thing for red, green, and blue. So this is starting with a monochrome intensity and then a color, and then so it's using the monochrome intensity to come up with the brightness, and then the color and the intensity to come up with the color. This is probably what people are most interested in. Maybe this is something to do in, what was that cool graphing tool? Is this the one I was thinking about? Oh, maybe it is. So we're starting with a sine wave, right? And I wanted to change the sine wave's shape so that it, first of all, sits above the axis. So now, instead of going positive and negative, we just have these periodic blips. And then I wanted to make them much sharper so that instead of that kind of even ratio between things being bright and things being dim, I wanted to really bunch up all the brightness into a smaller part of the function. So that's why I have this really high power. Can I do this? I don't think I can do that. I think I want that. Yeah, so if you start this with 1, that's our regular sine wave. But then as you start increasing this, you can see that it changes the shape such that it's a lot like how specular highlights work. You're taking that function that would normally be spread out across a long area, and if you think about it on the y-axis, it requires a lot more input, upness on that y-axis in order to give you the same output. So this, yeah, I don't know if that's a really good explanation, but oh, Mikhail says the camera overlay eats the code a bit. I can turn that off. So yeah, I don't know if that really makes sense. And this would look a little different if I had parts of this going below the axis too. So if I hadn't shifted it up like that, you can see this starts to look pretty much the same if I use an even power. If I use an odd power, you can see that now I have the negative part of that waveform also, which I didn't really want. So, I could have used an odd power like that instead of shifting up the waveform. If you use a fractional power though, then yeah, these are now imaginary numbers. And so you could solve that by using an absolute value, but if you make this an absolute value, then there's actually a little discontinuity there, and it's a little smoother to not use the absolute value, but instead to offset it. So anyway, and then what else am I doing here? So these parameters for the sine are just advancing through here at a different rate, first for the entire LED strip and then next for the frames. So you can imagine just taking this entire function and mapping it onto the length of strip. This scaling up here means that every 30 LEDs I have basically a unity input to this function. So if I multiplied this by 2 pi, then every 30 LEDs would be 1 cycle through the sine wave. And then likewise, this is a factor that every frame that elapses, I'm shifting this by a little bit. I think that's pretty much everything that I was doing there. So, another way to do this would be to think about sampling every LED. Well, let's have 2 blips that move around independently as an example here. So let's say maybe each of these has a yeah, maybe each one just has like a position and a color to start with. So let's make a few of these slightly differently. So the position, let's just have all these kind of cycle around at different rates. So that'll be the one we have right now. That's a speed, red, green, and blue. And so that's our kind of, or maybe it isn't red, green, and blue. Maybe that's blue, green, red. Yeah, maybe I have these colors in the opposite order. Anyway, it doesn't really matter. Let's just give it a different color. I don't really care what color that is right now. And then maybe one of these can be going backwards. Okay, those are pretty arbitrary. I just have some different blips. And then I think I'm just going to try something where let's just try accumulating everything as floating point and then adding the brightness calculation on top of that. Oh, and Mikkel is asking how the 0.8 and 1 and 0.2 relate to colors. So these are going to be brightnesses between 0 and 1 for the red, green, and blue channels. So if you're used to seeing like web style colors, then this is just the same as like 0 to FF. I just have it scaled differently. I mean, down here it's going to turn into 8-bit colors anyway, but it's useful for writing like shaders and other kind of graphical algorithms to think about colors as 0 to 1, because then you can multiply colors together. So I'm going to generalize this slightly, so instead of red, green, and blue, I have channels, or maybe just call this RGB. Oh, no, I'm changing my mind. Let's do that up here with floats. So I'm also thinking maybe this would be easier if I was using numeric Python. Because, you know, you can just do stuff like that with numeric. Numpy. Oh, if I'm going to use numeric, I mean, actually, let's not open that can of worms, because I would probably write this completely differently if I was using numeric Python. Let's just keep this to one paradigm for the moment. So here I just want to get a measure of the overall brightness and do some kind of fake high dynamic range scaling. So I'm just going to add up the red, green, and blue and then take that to a power so that I get something that is kind of disproportionately high only when my colors are really bright, and otherwise is actually pretty low. And then these, oh, I already had the plus 0.5 there. And can I do that with some? Yeah. Okay, so then this should be my kind of consolidated red, green, and blue for all the channels. Or for all the blips, rather. Oh, and then Mikhail is asking, how do those max and min work? So this is clamping it so that I only get values between 0 and 255. So you can see how, like, if this value in here, so this whole line here, all this is doing is converting from 0 to 1 values into 0 to 255 with clamping. So if this is 0, then the output's going to be 0. If it's negative, the output's going to be 0. If it's 1, the output's 255. If it's over 1, the output's still 255, etc. And here, I just want to basically accumulate the brightness of each blip together. So again, this is setting the width of the blip, but then the center of the blip is actually going to be, it'll be defined by one of these up here. And let's actually enclose this in another array. So now this is center and then color. We don't have to think about red, green, and blue separately. So this is calculating the blip intensity. Oh, let's calculate the blip intensities separately. Intensities. Let's set this to so this is calculating how bright each blip is at the current pixel. And I'm not using the color, I'm just using the center for now. And then for the colors down here, that looks a little gross, but this is indexing into this blips array here and getting the current one, and looking at the color and the channel. I could do this slightly different. I could do tint. So that's going to go through each of the blips and multiply, well, and each of the color channels, so red, green, and blue. Multiply this tint value, so this is like a scaling factor for each of red, green, and blue. Then it'll multiply that by the calculated brightness, and then add those together. Let's see if that works. I think so. Let's get the camera back on. So yeah, you can see we have differently colored blips moving back and forth. We should have two moving in one direction and one moving in the other direction. And when they kind of combine with each other, they fuse and the colors add. That's fun. I still kind of want to know if the level shifters are mandatory, since we never really determined whether the level shifters were necessary for this to work out. So yeah, let's try that. I'm just going to unplug this little fade candy board and plug this more directly in. Oh, it looks like it works. Well, that's convenient. Well, cool. I mean, I could use this level shifter for, you know, it's possible this helps with reliability, but it's nice to know that it doesn't seem necessary. I can't completely unplug that right now because I'm using it as ground. That's fine. Oh, what just happened there? Is that a hardware or software glitch? I've been seeing these glitches periodically from the Raspberry Pi. I think that might be a Raspberry Pi thing where, I mean, not just like a Raspberry Pi issue in general, but like something else I have running on the Raspberry Pi might freeze it occasionally. And something I have running on this Mac seems to be beach balling my terminal. Oh, James said that they briefly see a mention that they work on 3.3 volts on one of the pages that I brought up. That sounds about right. I mean, I've seen pages saying they don't work reliably on 3.3 volts, but I would have expected a lot more pages on how to level shift them if they didn't work at all. So yeah. Let's make the... I'm not happy with the brightness scaling on this right now. I think this needs to be a much higher power. Well, that's definitely frozen. What happened there? I wonder if that was an issue with the LED not taking the signal I was giving it, or an issue with the computer being unresponsive. Okay, let's set this brightness to a constant value first and look at it just with a constant max or overall brightness. See that nice long tail there? I mean, maybe you don't on the camera, but in person it looks really nice. I think I want to avoid using a brightness value of 0 unless my brightness actually is 0. So maybe... maybe I make this 1.0 plus. Oh, now there's like a long tail and then a really bright portion. It's tempting to make this logarithmic. Mikhail says if I print the time since the last loop, you can determine if the freeze is Raspberry Pi related or LED related. Kind of, except that would also implicate the network because I'm SSH'd into the Raspberry Pi. If I really wanted to do that test, I'd probably want to connect locally to the Raspberry Pi over serial or HDMI or something. So I don't think that's quite what I want. I think I do just want this to be... I don't quite know how this does keyboard. Oh, like that. So, I mean, this is kind of what we're doing right now. We're just using this little bit of it, basically. I don't think that's quite what I want. Yeah, I don't know what's going to look best. I'm just thinking about I'm just like imagining the shape of the curve that I want, and I can play with these all day. Maybe I just want more like a gamma curve. Maybe just... more like a power of 5 or 6. What am I even doing here? Anyway. looks a little nicer. We've still got a nice long tail, but then it's pretty bright in the middle. Maybe a higher power would help. Should maybe also reserve some of those high powers for stuff that ends up above 1.0. So then you'll see it when the blips merge and we end up summing them into values that are over 1, you'll start to see the higher end of the brightness range. That's kind of nice. Gets a bit of a stair-steppy effect. The brightness change being so abrupt. Oh, I see. So Mikkel was suggesting just to calculate the time diffs on the Raspberry Pi. Yeah, that'd be fine. We could do that. And then Jack was suggesting e to the negative 1 over x. That's kind of nice, isn't it? Yeah, maybe that's what I was looking for. So what about negative e over x? Yeah, I guess we can do that frame rate test, and then maybe that's a good wrap-up point for this, because I think this is getting a little undirected. I don't want to print this every time, because that's going to affect my frame rate. Oh, keyboard. I don't know why I keep having to reset this keyboard. I mean, I assume it's something to do with signal integrity on this USB mess that I've got going on. Let's do every 16 frames. Is that all Python code being slow, or something else going on? Because, I mean, this is running on a Raspberry Pi. What if I have fewer LEDs? Oh, yeah. That's a problem with my Python code being slow. So, there's that. If we were going to keep doing this in Python, we'd definitely want to use numeric. I don't really know what language the bulk of this is going to be written in, though, and so may or may not even be using Python. We could try rewriting this in numeric just for fun. I mean, that section of it that's running quickly looks nice. Oh, we could also just run it on a more powerful computer. Let's try that. Let's go back to 200 LEDs. So there it is, running super slowly. Oh, it does perk up a little bit. Maybe that's the, maybe there was something else running on this Raspberry eating CPU, or maybe that's just the Python interpreter varying in speed depending on what I'm doing. Oh yeah, so Aaron's already given me optimization tips for Python. Like so I don't even know what language this is going to be in, or like how much work I feel like spending on it, but like, yeah, definitely this could be faster with NumPy. I just don't even know if I want to do that, because I don't really want to be writing LED code in Python. I'd kind of rather write this in C anyway. But it mostly makes sense just to write this in whatever language the rest of the robot's written in. Anyway, let's just run this on the Mac briefly. Oh, come on, keyboard. Oh, Beach Ball City. Oh, why am I in Beach Ball City? Why is terminal using 800 megs of RAM? Hello? Okay. So then this will need a network connection. There it goes. Something else to maybe cause problems with this USB hub. Oh, why? the one I'm looking for. Ah, much better. Look at that CPU core fly. So, that's a good stopping point, maybe. I think the next thing on my own yak shaving list was to write a driver for the strain gauge, but that's such a big change in topic that maybe it's probably good for me to end the stream before doing that. So that's great. That's just Ethernet from this iMac going into this TI board, then just connected to the APA 102s. Running some code that we just hacked up. And it's only running at 70 frames per second on this, what is this, like a Core Duo 2 or something? So yeah, definitely not the most efficient code, but it works to test the LEDs. A little bit warm. Yeah, the dynamic range is nice. I really like how these APA 102s have that separate brightness register. I still need to figure out how to most effectively use it in the software to get all all of that dynamic range out of it smoothly, but it is nice. And they definitely look better on camera than most of the stuff I debug. Oh yeah, Mikkel says, puts into perspective just how efficient GPU code is for games and such. Yeah, for sure. I've definitely, well, not for stuff that I've worked on, but I've definitely seen GPUs used for good effect on LED stuff. There was a big thing that I was helping out with ages ago that they were trying to do all the LED calculation in software on Java, and it was like bogging down their laptops. But doing it all in a shader is nice and fast. So far, I don't know, my favorite just kind of workhorse of fast LED code is this thing I wrote in C++ a while ago for Fade Candy that just splits off all the LEDs onto their own threads, and it can just like run, it can run your C++ LED shader code basically across as many cores as you want. So I'll just throw that on like a quad-core ARM embedded system. But, I mean, I don't think I need anything like that. I mean, if I wanted to save CPU on the transmit side, I could certainly do more work on the microcontroller and, for example, have some frame templates that represent individual, like these little blips that are moving around. Those could just be like lookup tables that it can move around and add. And that could all be done in ARM code on this thing really cheaply. I could even use floating point if I want. I've got a floating point accelerator. But it probably makes more sense just to do that on the transmit side and write the code more efficiently. So I'm just going to avoid going too deep into that until I know more about what language that code is going to be written in and what frameworks I'll be using and that kind of thing, because otherwise I think I'll just be ending up spending time on throwaway code. Oh, nice. Sodium was saying, I'm really enjoying the way the microscope monitor looks with the light leaking in from the microscope feed and the diffuse reflection of the blips. Yeah, and I didn't even notice, like, oh, where is that? Oh yeah, it's in that camera. So the HX711 that I'm writing a driver for next is going to be kind of interesting. It's just an SPI device, basically, but it requires a very specific number of clock pulses. So I might have to break the transaction up into a couple of pieces and change the SPI module configuration in the middle of it. Oh, Mikkel says, maybe as a last test, what happens if you make the sleep shorter? Good question. Well, it should just go faster up to a point. If I get to the point where I'm actually sending packets faster than the micro is processing them, then I could end up like canceling the DMA in the middle of a frame, which has unspecified consequences. So that might be an issue, but let's just see what happens. Let's go back to this screen. So let's just, we're taking out the sleep. If I take it out entirely, then this will probably get laggy because I'll be filling up the network buffer on the transmit side. If I make the sleep much shorter, so let's say it's a 300th of a second. I think I'm limited by CPU speed at this point. Oh wait, am I editing the wrong version of this? I think I might be editing the one on the Raspberry. Make sure we're editing the right version. Oh yeah, now it's running at like 160 frames per second. Let's try just no delay and running it as fast as we can calculate it using our slow Python code. That is 400 something frames. Let's look at that on the O-scope. This sure is blinky. Oh, putting this on the O-scope seems to be messing up my signal integrity. Unless I was shorting it. Oh, maybe I was just shorting it. Maybe I wasn't even getting... I think these pins that I'm using are just kind of short. Oh, it looks like I'm still not saturating my SPI bus. Okay, well this is electrically having some problems here, but there we go. Let's get the scope back on the screen. There we go. That is much better. So there's our 10 megahertz SPI signal. There's our pixels. There's our frame rate. Frames coming in. With only the slightest of delays in between. Yeah, I think we can send frames to this as fast as we want. Can we maybe slow down the animation a little bit so we can see it running this fast? Let's just divide everything by 10. So now we are updating the LEDs at almost 500 frames a second. It's pretty nice. It's really remarkable how little code it takes to glue some LEDs to the Ethernet. Len says, it says flyer firmware. Is this to annoy Tuco? Tuco's like, meh. Flyer firmware. Where does it say that? I mean, that is what we're working on. This whole project is called Tuco Flyer because it's a camera that kind of flies around to hang out near Tuco. I'm hoping it doesn't annoy him. Part of the design goal is to make it not annoying for either Tuco or myself. So, you know, it's not going to be like a quadcopter, it's going to be hovering around quietly on nylon cords. Oh yeah, no, this is about Tuco Flyer. So this is, I've been working on the firmware that goes on the robot that hangs out with Tuco and aims the camera and all that. And so this is just kind of putting the finishing touches on that firmware and giving it an LED output port so that I can send pixels to some pixel devices that are flying around the room, which seems fun. And also potentially useful for navigation and letting people know there's a filming robot nearby. Anyway, I think we're about ready to wrap up this stream. I'm probably going to go spend some time banging my head against data sheets for a while, but then I'll be streaming once I get back to something that's actually interesting. Oh, I see. I guess I misinterpreted. So as Zizarek said, it'd be interesting to see the FPS on the Raspberry Pi with no sleep. Thanks for bringing that to my attention, Mikkel. Yeah, let's plug this back into the Raspberry. I don't think that was going to help too much because the sleep was just taking up only a very small proportion of the time that I was spending on the Raspberry. What did I just do? What did I do? Okay, that's working. Let's get this back on the Raspberry. So that involves yanking the network interface from the Mac, plugging it in here. I think I got Network Manager on the Raspberry to set this one up automatically. Yeah. Alright, let's take out the sleep. Alright, well that was with no sleep. So the sleep is just taking up a very small proportion of the total time. So even with no sleep, we're still getting like 20 frames a second. James says, hang a nylon bolt from the flyer by a thread. Yeah, that would definitely do it. The trouble with that is then Tuco would be breaking the flyer every time. I think he would enjoy the bolts the most if they were being flung from kind of close to the ground, because then he could follow them right away. But yeah. Yeah, no, I mean, this code is extremely inefficient, so I'm not really fussed by the fact that it's running so slowly on the Raspberry. I mean, I'm not planning on using a Raspberry for this long term, first of all, and even if I was, I would just write more efficient code, either faster Python code or write this in a different language. But even within Python, there are a lot of options to make this go faster. Like, this is one of the slowest ways you could do it. I was just trying to do it quickly. Aaron says, I wonder what's bogging it down so much. Well, let's count the ways. I mean, there's a lot that's going on in here that's slow. So every single pixel involves all of these function invocations, which are just slow to begin with. It also involves like creating an enumerator and looping. So like there's just all these low-level operations in Python that are not fast to begin with, and I'm doing them per pixel per frame. So it's just not the right way to write code quickly. It's the way to write code such that it's kind of straightforward and fast to write, at least if you're me. So there are a lot of different ways to do this. But yeah, if I was trying to do this fast in Python, what I'd probably do is just try to restructure this so that I'm operating not per pixel, but on the entire array all the time, and use numeric Python to handle that. But I'm not really in the mood to do that right now, and I don't know if it'll actually be useful for this project, because I don't know if I'll be writing this in Python. I forget whether I did that with Fade Candy, because I know at some point I wrote some numeric Python code for Fade Candy, but it's such a hard thing to get people to kind of paradigms shift into thinking about when they're new at programming, because numeric Python is kind of a totally different way of thinking about programming. You know, you're thinking about like arrays flowing through this kind of data flow contraption that you're setting up, rather than just like, I want to do a thing with a number, which is usually how people approach it. So for teaching, I would tend to avoid numeric Python just because it's kind of this extra layer of complexity that I want to avoid. And then for my own personal stuff, I think even with numeric, it would tend to not be fast enough for a lot of the stuff I wanted to do, so I ended up writing C++ code. I mean, the thing that I wrote in the past to do this is maybe what I would just end up using. So it's in the Fade Candy repo. Fade Candy is just a project that I did a while ago for making an LED controller over USB. But it's also got a bunch of user space code that just, you know, there are different paradigms for putting together pixels for LEDs. And this one that's written in C++ is kind of the one that I ended up using for most of my own stuff. So the effects are written as C++ functions, pretty much like what we were just doing. There's a shader here. This is the position of the LED that we're calculating a color for. This is like any extra info that's attached to that LED. And then it calculates the color by sampling a mathematical function, and then returns the color. So this exact same code would probably work for what I'm doing now. I would just glue it to like some UDP packets instead of OpenPixel control. This is like a header-only C++ library. Very similar overall, except this is using TCP, which is kind of nice when you're dealing with software that likes sockets, but for lower level stuff, it's kind of handy to just be dealing with packets. Anyway. Oh yeah, so as Michaela asks, so in C++, would you do similar pseudocode to how you've set up the current Python script? Yeah, pretty much. I mean, this thing that I did with returning a function in the shader is kind of a different, like I would do that differently in C. I would have this kind of set up potentially a structure full of data that's format is known to this module, but not necessarily outside. Yeah, I would organize this slightly differently, but this is basically the same idea. And if you want to see how I would choose to map this to C or C++, then yeah, it's pretty similar to what I've done in the Fade Candy repository. So So I hope some of that was interesting. Dave is asking, would adding phantom LEDs between these LEDs make sense to get a better slow fading? I think what you're talking about is position oversampling. So the slow fading, like that's entirely about temporal resolution. So if nothing was moving spatially and we were only fading them, then positions don't matter at all. And the smoothness of the fade just depends on things like how you're calculating the brightness, how you're expressing that brightness between your calculations and the LEDs, how the LEDs are doing their pulse width modulation, you know, whether you're sampling at a regular interval, whether you have kind of hard edges, or whether you can kind of smooth that out. Then there's the issue of spatial sampling. And so if you're moving something across it, like imagine you have a function that just goes from all off to all on. So it looks like the edge of a square wave moving across your LEDs. And then as that square wave kind of hits another LED, that one just goes all the way on. That would look really jerky. One way to make that look smoother is to kind of like anti-alias your LED. So imagine each LED isn't sampling at one point, but it's actually sampling at this kind of fuzzy region that's centered around its true location. And then if you did that, then instead of seeing that square wave move across and just each LED turns on instantly, you would see each LED kind of fade on as it kind of fuzzily acquires the edge of that square wave. So that's definitely something that helps with some kinds of LED animations. And just like with GPUs, you can achieve that effect just by taking a bunch of samples that are spatially separated and then averaging them. You can achieve it by smoothing out your source material so it doesn't have those high frequency components to begin with. A lot of the same effects that you would do in two-dimensional graphics work with like one-dimensional and three-dimensional stuff with LEDs. So yeah, a lot of the same techniques. I definitely found that, you know, every project I've done with LEDs, I kind of end up thinking about it a lot like, right, I think about graphics code. It's just slightly different domain. But yeah, thanks for watching, everyone. I'll be doing more of this soon. I think the plan at this point is, now that I've got this pretty much done, I think I'm going to switch gears for the flyer, so that on the flyer I'm just working on CAD, and I might stream some of that soon. Might do some of that off camera depending on how interesting it ends up being. But yeah, the flyer needs some CAD so I can actually start putting this together so that it isn't just a pile of parts on my desk. And then the winch, once I get some of those boring drivers put together, so like once it can read the force sensor and the quadrature encoder, then I'm going to start working on motion control algorithms, which should also make some interesting streaming. So yeah, lots to look forward to. And if you only watch these streams and you haven't been aware of some of the other stuff I do, I also do these edited videos. Like nominally, a lot of what I'm doing here is collecting material for these kind of more polished, edited together videos. And so, you know, a lot of this is just going to be kind of yak shaving that's not really interesting enough to end up with, end up in there, but pretty much everything I do ends up there in some form or another. So I've got another kind of long release there if you're into like a pretty whirlwind hour of hacking. I've got a new video out that covers the firmware modifications that got us to this point with the gimbal. So yeah, moving things in breakage, definitely a lot to be done with the motion control algorithms. So, and then there's the cat, as always. Oh, and thanks for the link from Sodium in the chat. All right, take care, everyone. Happy hacking.